Finally, let's talk about using absolute values when solving inequalities. This is where the formal definition of the absolute value will be useful. The formal definition of the absolute value of a is the distance a is from 0 along the number line. If we have a number line written out with 0 right in the middle, it doesn't matter whether a is a negative number or a positive number. The absolute value of a is just the distance from 0. So how would we solve the following? If we have an inequality that says the absolute value of x is less than 2, we mean that the distance from 0 is less than 2. Let's draw out a number line. 0, 1, and 2, written out right here, -1 and -2. We're looking for all the points whose distance from 0 is less than 2. 0, the distance from 0, is 0, which is less than 2, so we're good to go. 1, the distance from 0, is also less than 2. But for numbers 2 and above, these don't work because the distance from 0 is bigger than 2. Similarly, -1 or -1.5 or -1.9, the distance from 0 is indeed less than 2. What we can conclude is that going from -2 all the way up to +2 and everywhere in between are the points that satisfy this equation, which we can write as -2 is less than x and x is less than 2. As it says, since the absolute value of x is the distance from 0, we want all the numbers whose distance from 0 is less than 2, just as we concluded. We can use this idea of drawing out a number line in general to try and figure out our solution moving forward. So how would we solve the following? The absolute value of x is greater than 5. Well, using our definition, the absolute value of x is the distance from 0, so we want all the numbers whose distance from 0 is more than 5. So all these numbers like 1 and 2 and 3 and 4, they are quite close to 0. They would not count. In fact, even 5 and -5 would not count because their distance from 0 is not greater than 5. It is 5. However, numbers bigger than 5, like 6 or 7 or 8, their distance from 0 is quite large. And numbers smaller than -5, their distance from 0 is also quite large. In both cases, greater than 5. And that means we could write this as two different inequalities. X is less than -5, or x is greater than +5. With this in mind, let's talk about the strategy for solving absolute value inequalities. As before, we want to isolate the absolute value on one side of our inequality. If our absolute value is less than or equal to some number, we'll create a compound inequality where we will have negative whatever is on the one side is less than or equal to x is less than or equal to a. On the other hand, if our absolute value is greater than or equal to some quantity, we'll have two separate inequalities. X is greater than or equal to b, and x is less than or equal to -b. And finally, we will solve all of these remaining inequalities that no longer have an absolute value in them. Let's check out an example. We want to solve the inequality absolute value of x minus 3 minus 6 is less than 2. As always, we want to simplify everything so that the absolute value is on its own. So this would become the absolute value of x minus 3 is less than 8. We'll notice that we have an absolute value is less than something, and therefore we want to create a compound inequality where negative 8 is less than x minus 3 with no absolute value, and x minus 3 is less than 8. Instead of treating this as two separate inequalities, we can solve it at the same time, solving for x, just by adding 3, not to both sides of an equation, but rather to all three sides of this compound inequality. And therefore, we get negative 8 plus 3, or negative 5, is less than x minus 3 plus 3 is x, is less than 8 plus 3 is 11. On a number line, we could draw it out where negative 5 is here, 11 is here, and we would use round brackets like this. Alternatively, we could write this in interval notation as negative 5 comma 11, indicating that x is in between those two, but not including either endpoint. Let's try one more. Negative 3 times the absolute value of 2x plus 1 is less than or equal to minus 9. So we've got to keep two things in mind here. First of all, when we're simplifying our left-hand side by dividing by minus 3, we have to switch the direction of our inequality since we're multiplying or dividing by a negative number. That means after simplifying, we have the absolute value of 2x plus 1 is greater than or equal to negative 9 over negative 3. That's positive 3. As before, we have an absolute value this time is greater than or equal to 3, which means we have to split this up into two separate inequalities where 2x plus 1 is greater than or equal to 3 if this quantity was already positive, and where 2x plus 1 is less than or equal to negative 3. We can solve these one at a time. Let's say we subtract 1 from both sides. 2x is less than or equal to 2. X is greater than or equal to 1. And for our second inequality, if we subtract 1 from both sides, 2x is less than or equal to minus 4. X is less than or equal to minus 2. Once again, if we wrote this out on a number line with 1 and minus 2, we would have all the points to the left of minus 2, including minus 2, and all the points to the right of 1, including minus 1. There isn't a nice way to write this in interval notation, so we could just write this is going from negative infinity to minus 2, and then we could write or, with a big U, 1 up to positive infinity, and that would be good enough.